Okay, solving problem 41. So we're taking a look at solving for the solving for the variable here using any one of these different processes. So the first one, if I take a look at that right here, basically for this one I'm going to do a lot of undoing. So if I take a look at that first problem, 3y plus 1 squared minus 5 equals 43. If I think of the order of operations, PEMDAS, and I write it this way because multiplication division comes first left to right. Whichever one's first, left to right, I do first, and same with addition and subtraction. Whichever one comes first, I'm going left to right. So it's not necessarily the M before the D or the D before the M. It's whichever one comes first, and same with addition and subtraction. When I'm solving an equation for a variable, so this one I'm solving it here for y, I'm actually doing PEMDAS backwards. So what that means is I want to get rid of anything that's being added or subtracted from the y. Well, here's y, there's a 1 being added to it, but that's inside of the parentheses and also has an exponent on it, so I'm not going to do that first. The 3 is multiplying it, so I'm not going to do that first. So on this problem, the first thing I'm going to do is get rid of the negative 5. So to undo that, I add 5 to both sides. So I have 3 times y plus 1 squared equals 48. Then I take a look at anything that's being multiplied or divided. Well, 3 is multiplying it. So I'm going to undo that, and to undo that multiplication there, I'm going to divide by 3. That gives me y plus 1 squared equals 16. Now I'm going to take a look at any exponents. Well, I have something squared, so to undo that I'm going to take the square root. That gives me y plus 1 equals, now positive or negative 4. I get both the positive or negative. And because if I do the looking inside idea, whatever I have here squared, if the y plus 1 was positive, it'd give me 16. If the y plus 1 was negative, it would give me 16. So both could be positive or negative, and that's why we do that step. That now gives me 2 different answers. So I'm going to subtract 1 from both them. So I have positive 4 minus 1 is going to give me 3. And I also then have a negative 4 minus 1. And that gives me negative 5. Those are my 2 solutions for problem A. On to problem B. I'm going to go through this one a little bit quicker, but the process is still the same. Looking at what I have here, undoing the square root is the first thing I want to do. So I need to square both sides. That's going to give me a 1 minus 4x equals 10 squared is 100. Getting the x by itself means I need to add or subtract 1 from both sides. So I have a negative 4x equals 99. And now to get x by itself, I'm going to undo that multiplication. So I divide by a negative 4. So x equals a negative 99 fourths. I can leave the answer like that. If you want to convert it to a decimal, that's perfectly fine as well. But negative 99 fourths. On to problem C. Now problem C, there's multiple ways you could solve these, and there's multiple ways you can solve any of these 4 problems. But in problem C, one of the first things I'm going to do is move the negative 3. So I'm going to add 3 to both sides. I also have a y in the denominator, so I'm going to use fraction busters and multiply everything by y. I could do it right now first, but instead of doing it right now, I'm just going to add 3 to both sides. So if I add 3, I'm going to get 6y minus 1 divided by y equals 5. Now when I use my fraction busters, I multiply the entire thing by y. So that means I distribute the y to the numerator here, and I distribute the y right here. Now when I do that, y divided by y, that makes my giant 1, and I'm left with 6y minus 1 equals 5y. Much easier problem now that I no longer have fractions. I'm going to subtract the 6y from both sides, giving me negative 1 equals a negative y. And if negative 1 equals negative y, I divide by negative 1. Because of that, I'm not dividing by that negative 1. I'm dividing by this negative 1. That gives me a positive y equals a positive 1. And the very last problem, problem D. Again, undoing this problem, I'm taking the third root of everything here. So in order to undo that third root, I'm going to cube everything. The cube root and the cube undo each other, so I'm left with 1 minus 2x equals, and then 3 to the third power is going to be 27. Very similar to what we did here in problem B, except for that was the square root. Now we're just doing the cube root. Very similar though in process. Now I go through and subtract the 1. I have negative 2x equals 26. Divide by the negative 2. And I get x to equal a negative 13. And that sums up problem 41.